Welcome back to the Home Lab, and I've got an interesting mathematical device to show you today. Styled by a Swedish prince and commonplace in offices in the 1950s, this is the Contex Model B adding machine. As you might know, I've got a real interest in old and unusual and obsolete calculating devices, and this is no exception. So what I'm going to show you today is how the Contex Model B works, and we're going to do some sample calculations. These machines were made in Denmark by Contex, which started in the 1940s, and the Model B came out in the 1950s and sold literally in thousands. And would you believe this futuristic, updated design from the Model A was done by Sigvard Oscar Friedrich, Prince Bernadotte, Count of Visborg. He was Swedish royalty, no less, and a celebrated industrial designer. So let's do some sample calculations on this device, and then I'll open it up by taking the screws out the back, and I'll show you how the mechanism works inside. So to start with, let's do some simple calculations. And before we do, you'll notice the keyboard is broken up into different areas, and I'll explain that in a minute. And we've got sort of some fraction keys here and keys that look a bit different. And you'll also notice, for some reason, there's no 6, 7, 8 or 9, and there's no 0 either, but we'll come back to that. So the first thing I want to do is use these black keys here, so ignore those numbers and we'll look at these black back numbers that are printed in white for our first simple calculation. So let's do 5 plus 4 plus 1. So there's 5 plus 4 plus 1, and you'll notice it carried to 10. We can reset by pushing this all the way down and letting go, and that's our reset. So that's how you do a simple calculation. The main thing to notice is you've got to press the key the whole way, because you'll notice I only pressed 5 a little bit there and it only clocked on 3 places. So if I press 5 properly now, it should go to 8. There we go. So there's very little sort of error correction or things to make sure that you don't make an error, and the Sumlock and Comptometer had devices to do this. So this one, you've got to be really careful to push the keys and watch the carry all the way down. So to show you one other clever little feature of this thing, and one thing that makes it really, really fast, is I'm going to do 222 plus 333. So this is the slow way. I've got to reset first, remember. So 222 plus 333 is 555. Reset. But of course the quick way is to make sure you press all the keys, but press them down the whole way. So 222, 333, and there we go, 555. So that's very quick and something you can't do on a modern pocket calculator. But what I hear you say about something like 15 plus 68? Oh, there's no 6 and 8. Well, I'll show you how to do that. And it's really clever because this has a half keyboard. And so what we can use is numbers on here that add up to make the numbers that we want that are higher than 5. So let's reset and watch the reset process. So there's our 555. What happens is it goes to 999, or at least the highest number on all the dials. And then when we let go, it adds 1. There we go. So that's reset. So we were going to do 15. There's our 15. Plus 68, 5, 6, 5, 6, 7, 8, and there it is, 83. So what we did to get the 8 is we hit 5 first and then added 3 to it for 68. And to get the 6, we press 5 tens plus another 10 to get the 6. And when you get the hang of that, it's really quick. So let's try a slightly more complex calculation with bigger numbers, and you'll notice that I'm not a skilled operator, so I'm going to press with one finger, but a skilled operator would probably use all 4 fingers at once to type in one whole number there. So we're reset, so let's go 1234 2,345, 1,122, 5,000, and there's the 2, and finally 23, and that gives us 9,726. Now, let's add some numbers that are a little bit larger, and you can see how we have to use this keyboard that doesn't have any sort of 6, 7, 8, 9s on it. So we need to reset. I sometimes forget to do that. And again, remember, I'm really slow, but a skilled operator would go chunk, 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 and they'd be done. So bear with me whilst I do a really slow example. So 1,234 plus 8, well 5, 6, 7, 8, so add 3. For the 9 we need 5 and 4. For the other 9 we need 5 and 4. And for the 6 we need 5 and 1. You get good at this, of course. 5,700, so that's 5 and 2. 23. 12, well that's easy. And 1,006, there's the 5 and there's the 6. And let's see what we get. 16,971. Now you might wonder how you do multiplication and things like that, and I'm not going to go into that in detail, but it's pretty obvious. If you want to do simple ones like 3 times 3, you just do 3, 3, 3, 3 times 3 is 9. If you want to do something a little bit more complicated like 531 times 7, 1, 2, 3, 4, 5, 6, 7, and there it is, 3,717, and obviously you can do that really quickly. There are loads of other techniques, but the purpose of this video is just to show you how the basic functions of the machine work. However, brace yourselves for this, mine was designed for pre-decimalisation calculations of money. So it's got these extra keys, so let me see if I can explain those. And apologies to those of you who are old enough to remember the pre-decimalisation that happened in 1971. I was around then, but far too young to start buying things. So on this side we've got farthings, and in 1 pence, 1 penny, were 4 farthings, quarters. So there's 1, 2, 3, 4, and you can put 2 farthings in by just doing that. So I'll just reset that. The next thing is there were 12 pence in a shilling. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's the 11, and 12 carries to 1 shilling. Right, you're still with me. There were 20, this is so obvious, isn't it? There were 20 shillings in a pound. So this white area here is the shilling. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 shillings. 11, 12, 13, 14, 15, 16, 17, 18, 19 shillings. And get ready for it, 20 shillings were £1. And then from here onwards, it's just pounds. So it gets much easier. So let's see if we can do an addition on this machine using pre-decimalisation money. And you'll be glad that you had a machine like this, because I find it really complicated to do in my head. Okay, you ready for it? So here's something that my grandparents would have had no problem with at all, and shopkeepers would have done this really easily, even if they didn't have electronic tills. So it's £3, 13 shillings, 11 pence, and 3 farthings is going to be added to, I don't know what I'm buying here, it seems quite expensive, £5, 15 shillings, 9 pence, and 2 farthings. So we reset. Yep. So I'm probably going to get this wrong, but let's give it a go. So pounds, £3. There's our 13 shillings. 11 pence. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 3 farthings. So there's 2 of them. And there's 1 more. And we're going to add that to £5. So there's our 5. Plus 15, 1, 5 shillings, plus 9 pence, so 5, 6, 7, 8, 9, so that's our 4, and 2 farthings, so that's a half, and the answer we get is £9, 9 shillings, 9 pence, and a farthing. So that was easy, wasn't it? I don't know why we ever needed decimalisation. So let's have a look inside now. And if I turn it over, interestingly, you'll notice that, I'm going to twist it that way. If you can see that, it was bought from an office suppliers in Cambridge, Sydney Street. You can also see the serial number, and it's 239900. Remember, they built an awful lot of these. And I looked up at how much it would have cost, and I found the price in Australia, in Australian pounds in the 1950s. And it was £25, which in modern money in the UK would be about £500. So it wasn't a cheap calculating device, but one that made life much easier for accountants. One of the beauties of its design, I think, is just how easy it is to service. In other words, take apart and have a look inside to get at the working mechanism. 5 screws come off, and the 3 feet as well. And then you just lift this base plate off, and you can see the sort of inside workings there. And remember, it looks terribly complicated, but it's really typewriter technology. And then all you need to do is just turn it upside down and gently lift the top off. And that's it. That's how quickly you can get inside it, which I think's really clever. So let's have a quick look at the working mechanism. I'm not going to go into real detail on this, but there are a couple of little interesting bits about the mechanism that I thought you might like to see. So now we've got it out of the case, let me reset it. There we go. And you've got wheels here at the front, and it's a bit like an old-fashioned car speedometer, that when you press the keys, it sort of pushes them on one place. This, I need to lift it up to make the one go further. So it's just a simple sort of ratchet mechanism. And if you press the 5, it actually pushes it on 5 places. And there's your carry happening at the end. Again, I won't go into the detailed mechanism of how that works, but you can imagine a sort of an extra pin that pulls a cog round, and it pulls it round once, twice, etc. There are technical names for these things, but I won't go into that. Now, if I turn it over, it's quite oily, as you might expect. Each key has its own lever here, and it's made of that sort of material that printed circuit boards seem to be made out of. And it's quite interesting because when you press a key like a 5, it does sort of 4 clicks and then moves the 1 down to add the 5th click. So it's very difficult to see, but it's this leaf that moves, and it actually carries all the others with it, and then finally moves the wheel on the sort of last place, as it were. So it's really rather clever. It's sort of using the mechanism of the other keys to sort of add up. It's difficult to see how that works, and I don't think I've explained it at all well. But you can see how each key has its own lever, which presses down a different distance, and you can see the carry mechanism operating there as it clicks around. I don't have one in pieces that I'm willing to sort of tear apart to show you how the mechanism works in detail. But again, that wasn't the idea of this video. But isn't it clever what you can achieve with just a few levers, cogs and a few springs? You can make a calculating machine like this that will add up numbers way quicker than you could do in your head. So I hope you feel you've got a bit of a better understanding of how this lovely and old-fashioned calculating device works. Now, granted, it's quite complicated inside, but what you've got to remember is this comes from the age of typewriters, so there was plenty of places and plenty of people who had much experience in repairing these and oiling them and fixing the mechanisms. In some ways, internally, it's got a mechanism very similar to a typewriter, so it wasn't an unusual device to take into an office supplies company and get an overhaul done on. So many of these are still working perfectly well to this day. And in fact, mine was a little bit sticky when I first got it, but with a bit of playing with the keys and a bit of cleaning up, it worked straight away. And I'm sure this will work well for another 100 years. So that is the Contex Model B, not really a pocket, but desk calculator. And the operators who used these would get really, really fast with them and sort of touch type when they were doing their addition. And I bet you they could beat any of us today on our normal pocket calculators, especially when doing pounds, shillings and pence, because I find that really, really complicated. I can't begin to imagine what a room full of GCSE students doing a maths exam would sound like if they were issued with these. Anyway, it seems such a shame to throw this out and chuck it in a skip, which must have happened to thousands of them. So I'm going to keep mine, and I've really enjoyed sharing how it works with you. So I do hope you enjoyed that video on this rather odd and obsolete calculating device. And if you like this sort of thing, by all means put some comments below and ask me to make some more videos on topics like this. Thank you very much for watching as ever. Do stay to the end of the video because I put some links to other videos that I've made. But I'm sure if you join me soon, I'll have another interesting video for you then.